Good day, wonderful celebrity nation. We are here again in our Physics 102 to talk about motion of a charged particle in electric field. Today, as I told you in the last lecture, it was something different. So you need to pay proper attention to understand it perfectly well. Get ready. Let's do what we know how to do best. Now let's look at the lectural objectives. At the end of this lecture, you should be able to tell us every concept of motion of a charged body in electric field. How they operate, how they move, what caused them to move. You should be able to tell us that. And you must be able to derive the acceleration of the charged particles in electric field. Get the calculation and know how to solve problem with it. Then the equation of motion of charged particles in electric field. Let me call you back a little bit. You know your equations of motion, the Newtonian equations of motion. The first, the second, the third equation, and the fourth. Now we are going to use those equations for charges and know exactly how they are now. That's exactly what I want you to understand by the end of this lecture. So get ready. Let's look at the previous lecture revision. Our previous lecture was on electric field intensity. And we'll say that electric field intensity simply means the magnitude or strength of electric field. But mathematically, it is expressed as the force or electrostatic force per unit charge. Now, if you recall your Coulomb's law, you will see that Coulomb's law gave us electrostatic force equation, which said that F is equal to K, small letter q, capital letter Q, all over r squared. Where K is Coulomb's constant, it has a value that is approximately 9 times 10 to the power 9. And Q, the small letter Q, is the test charge, while the capital letter Q is a point charge it's acting upon. Now, the R there is the distance between the two charges. So, if we say that electric field intensity is force per unit charge, which I explained in that class, that per simply means divide or division. So if you say force per unit charge, it means force divided by charge. And the force we're talking about here is electrostatic force, which is KQQ over r squared. That is K, small letter Q, capital letter Q, all over r squared. That's the force. Now, divided by Q, that's what brought in times 1 over Q. So Q divided by Q, two of them will leave the system. So we have E equal to K, capital letter Q, all over r squared. And this is the formula for electric field intensity. So for the sake of examination, pay attention to these equations. E equal to force over Q and E equal to KQ over r squared for electric field intensity. If you need a total lecture on this, check our previous lecture on lecture 7, electric field intensity. It will do you a lot of good. The unit of electric field intensity is Newton per coulomb. And why is it Newton per coulomb? Force is measured in Newton and charge is measured in coulomb. So since electric field intensity is force per charge, that means the unit is Newton per coulomb. This is the revision of our previous class. Let's see what today's class holds for us. Concept of motion of charged particle in a field. What do we mean here by concept? We mean totality. How does it happen? How does charged particle move in electric field? First, we'll start by describing it for you, how it moves or the path it moves. So if we're able to express the path, we can now start talking about the equations of movement. Now, in terms of path or how it moves, a charged particle moves through a field in a parabolic path. What does that mean? No charged particle moves through a field in a straight line because something will happen. As long as the body is charged and is within the field, remember, field is caused by interaction of charges. So it's either the charge is being attracted or being repelled. So it's hard to have a charged body moving in a straight line in a field. So it moves in a parabolic path. That is the description of the movement of a charged particle in a field. We'll do this in detail. But if you look at the diagram you have, you'll notice that the positive charge moves in a parabolic path from up to down, from the positive part to the negative part. While the negative charge moved in a parabolic path upward from the negative to the positive charge. Now let's look at in detail what is happening here. Positive charge. Let's look first at the movement of the positive charge. When a positive charge is passing through an electric field, it will be repelled by the positive pole or terminal of the field and attracted by the negative pole of that field. So this will make it move in a parabolic path. Now pay attention, concentrate more on the diagram. Let's look at it together. If you look at the diagram, you see that you have two things like an iron bar. One is positively charged and the other one is negatively charged. And there are lines of force. Remember our lecture on lines of force. We said they move from positive. That is where they are generated. Then they are received by negative. So the line of force here, the lines on blue, are moving from the positive pole to the negative pole. Now, when the positive pole moves into the field, what happens? The positive charges at the positive pole will start repelling the charge, pushing it away. While the negative charges on the negative pole will start attracting it. So it cannot move on a straight line. Rather, what do you see? It moves in a parabolic path, just as what we see on the scoreboard there. So this is how a positive charge moves in electric field. Here, the charge is positive. It's a positive particle. Now, it moves in a parabolic or what we call trajectory path. If they ask you why or the reason, simply the positive charge from the pole is repelling that same positive charge because they are like charges. While the negative charge is attracting that charge because they are unlike charges. So at the end of it all, what do you see? The charge is running away from the positive pole and running to the negative pole, so it moves in a parabolic path. Let's look at the negative charge. Now, when a negative charge is passing through an electric field, it will be repelled by the negative pole and attracted by the positive pole, which will also make it move in a parabolic path. If in examination or assessment they ask you, what is the path of the movement of a charged body in field? The answer is simply parabolic or trajectory. Now let's look at the diagram again. You can see from the diagram the same thing. The lines of force are moving from positive to the negative. Now, but the charge, the red ball there, negative charge, entering the field, what happens? The negative charges will be pushing it away, while the positive charges will be attracting it. Why are the negative charges pushing it away? Because it is also a negative charge. They are like charges, and like charges repel each other. While the positive charge up there will attract it because they are unlike charges. So it will attract it. thereby causing the movement to be on a parabolic path. I hope you can be able to reproduce this any day, anytime. Now we are moving into the mathematical part of the motion of particles in electric field proper. First, I think what we need to derive is acceleration of the charged particle passing through electric field. You already know what acceleration is in our physics 101. Acceleration is the change in velocity per unit time. Yes. Or some people say it's the rate of change of velocity. But today we are looking at a different acceleration that has to do with charge. Mathematically, we want to derive something that you will not see velocity anymore, but you will now see something related to charge. Now let's start. If you remember, electric field intensity is giving us force per unit charge. That is the first formula you have there. E equal to F over Q. Now, if I make F the subject of the formula, check it yourself. We have F equal to EQ because E will now multiply Q, giving you F. Now, remember also that force, by definition, is mass of a body times the acceleration of the body. So, if force is equal to EQ and the same force is equal to MA, that means I have every right to equate the right-hand side together. Understand it. Don't get confused. If I say that x is equal to 2, y equal to 2, it simply means that x is equal to y. The same thing. Force is equal to EQ. Force is equal to MA. That means I have all the right to say that MA is equal to EQ. Since the left-hand sides are equal, the right-hand sides must also be equal. So equating both sides will have MA equal to EQ. Now I want to generate my acceleration A. Making A the subject of the formula, what do we have? A is equal to EQ over M, where E is electric field intensity, Q is the charge, and M is the mass of the body. And this gives you the acceleration of a charged particle passing through electric field. I would like you to get a paper and generate this yourself. And take this particular formula, A equal to EQ over M, very important, because either in your assessment or your examination, they must test you on this. This, again, I say, is the acceleration of a charged particle moving or passing through electric field. So anytime, any day, they give you some parameters and ask you to calculate the acceleration of a charged particle passing through a field, what they expect you to put down is this formula, A equal to EQ over M. You can pause the lecture, use your paper and pen, try to generate this yourself and know how to use it to solve problems. Let's look at something else. Now we want to generate the velocity of the charged particle passing through electric field. And my rule of teaching or lecture is start from what you know to what you don't know. I could have just put down the formula for you, but no, you need to know where it's coming from. Remember your basic physics. Your basic physics says that the first equation, Newtonian equation of motion, is that V is equal to U plus AT, where V is final velocity, U is initial velocity, A is acceleration, T is time. This is the first Newtonian equation, and it's generally accepted in physics. Now remember that we just generated over here in the previous slide. that A is equal to EQ all over M. We generated this here. So going to this point now, remember that A equal to EQ over M. So if I substitute the A equation, that means wherever I see A, in the first equation I have there V equal to U plus AT. That place I have A. I will replace it with EQ all over M. I did not commit any crime if I do that. There is no physical or mathematical crime. It's correct. Because if I say X is equal to 2, I can replace X in any equation with 2. And that's exactly what we're doing here. So the same equation that says V is equal to U plus AT is the same thing you're having where I say substitute the A equation. But what did we do? Instead of writing A, we'll now replace it with EQ all over M. So we have V equal to U plus QE all over M times T. Then there is something I want you to know. In your linear motion, in Newtonian motion, whenever we say a body starts from rest, it simply means that the initial velocity of that body is equal to 0. The same way, if we assume here that this body is starting from rest, since it's a charge entering the field, now let's say, okay, at the point of entering the field, the velocity there is 0. What happens? The U there will be equal to 0. So the velocity of the charged particle passing through electric field will become V equal to QE over M times T. That is the equation in the block space. Take that equation. Very important. The first equation I asked you to take important in this particular lecture is A equal to EQ over M. That is the acceleration of the particle passing through electric field, the charged particle passing through electric field. The second one is this one. This is the velocity of the charged particle passing through electric field. Now, we can also use another equation to derive the same velocity. Okay, let's look at it together. Here, I'm also deriving the velocity of charged particle passing through electric field, but with another equation of motion. This time around, not the first equation, but the third equation of motion, which says V squared is equal to U squared plus 2AS. The same thing, remember your acceleration, A equal to EQ over M. The first equation we generated in this topic. I'm not talking about the previous revision. No, in this particular topic, the first equation we generated is A equal to EQ over M. That's our acceleration. That means wherever I see A in the main equation I'm working with, which is V squared equal to U squared plus 2AS, I will replace it with EQ over M. So substituting the A equation means where I see A, I will put EQ over M. So we have V squared equal to U squared plus 2 bracket EQ over M times X. Now, assuming the same thing, that okay, entering the field, the acceleration, the initial velocity there is equal to 0. The initial velocity, let's assume that U is equal to 0. What happens? The U squared here will become 0 because 0 squared is equal to 0. So what do we now have left? V squared will now be equal to 0 plus 2EQ over M X. And 0 plus anything is that particular thing. 0 plus 2 is 2. 0 plus 1 million is 1 million. So that means V squared is equal to 2 bracket EQ over M times X, which gives us V now. If I want to find the value of V, what do? I take the square root of both sides. The square root of V squared is V. Then we have the square root of 2EQX all over M in block. That is the second equation of the velocity of the charged particles passing through electric field. That's another important equation you will note today. Remember, the first equation is A equal to EQ over M. The second equation is V equal to QE over M times T. The third equation is V equal to square root of 2EQS over M. Try and learn these things. Try and learn them because your examination must ask. And even if not examination, you need to enjoy the physics. Stop cramming physics, learn it. And when you know these things, you will play around with them. It will make you happy. You become a king in what you do. Okay, now we are through with acceleration. We've done a noble job in velocity. Let's look at displacement of a charged particle passing through an electric field. This time around, displacement. And you remember the equation of motion that discusses displacement. That's the second equation. The Newtonian second equation of motion. Some books too recorded it as thought. Says that x equal to ut plus half at squared. S equal to ut plus half at squared. This has nothing to do with your 102. This particularly is physics 101 that has to do with mechanics. But without it, you will not have the meaning of what we're doing here. Let's assume we just come in here now and start writing these formulas down. You wouldn't know where they are coming from. So you may not enjoy the lecture. So x equal to ut plus half at squared. What do we do? Just like the previous ones we've done. Wherever you see a, put the equation of a there that says a is equal to eq over m. And your answer will quietly come out. So we have x equal to ut plus half, instead of a, we now put eq over m, then t squared. Now assuming the same thing, that the charged body started from rest, what happens? Anything that is attached to 0 or anything that is multiplied to 0 goes to 0. 1 million times 0 is 0. So ut, that means if u is 0, 0 times time will still be 0. So x now will be equal to x plus s equal to 0 plus half QEM t squared. QE over mt squared. That now means that x is equal to half q over m t squared. Stating it as a formula, we have it that x equal to QET squared all over 2m. This is another equation you need to take very importantly. I would like you to do something for me. Without your pen, without your paper or writing it down elsewhere, try and comment any of these equations that you know of heart. Go straight now and comment at the comment section any of this equation that you know of heart. Try and do that immediately. QET squared all over 2m is the displacement here. The best engaging student on this particular assignment I'm giving now has a reward from me. The best engaging student. Go comment. If you know 1, comment 1. If you know 2, comment 2. If you know 3, comment 3. If you know 4, comment 4. Don't use books. Don't write them down and go and type it for me. No. Just try. Give yourself a trial. And I know what I will do. Thank you. Okay, now let's proceed. Drift speed. This is another place that students don't find funny. But what is drift speed? It is the total distance traveled by the particle per unit time. Remember, we said that the particle travels in a parabolic path. That means it may not travel all through the field. As it's going, at a time, it might sink in on the negative pole or on the positive pole, the particular pole that is attracting it. So that total distance traveled divided by the time of travel is called the drift speed. Now, if you remember that the displacement we just finished in the previous slide, the equation of displacement said that x is equal to qet squared all over 2m. And drift speed being v equal to x over t. That is total distance over time. If I make t the subject of the formula, what will I have? I will now have the total distance divided by the velocity. So, in this equation of displacement, if I don't want to put in the time there, I can also use the time equation, which is x over v, to replace my time, just like what we're doing with acceleration. So here, x is equal to qe. Instead of t squared now, I now put in x over v, all what? Squared. QET squared, then over 2m. But here, instead of this, what we'll now have is x over v all squared. And that is the displacement of the particular thing we're looking for. So the displacement any day, anytime, is giving us QE over 2m x squared over v squared. That is the formula for displacement with drift speed. I repeat, QE over 2m x over v all squared. That is our displacement with drift speed. But now some books just put it as total mass, or capital letter M, showing that this is the total mass of the system. In any of them, don't get confused. I restate it. Displacement is equal to QE t squared over 2m. Now, what you do is just to put the equation of x over v as t squared, and your answer will come out. Thank you, and have a wonderful lecture proceeding. Now, let's look at our lecture review. The concept of motion of a charged body in electric field. I know today you can be able to describe how it works. Yes, motion of electric field or motion of a particle in electric field is parabolic or trajectory. It moves in a parabolic path or in a trajectory path. Acceleration of the charged particles in electric field has been gotten as our equation, which says that A is equal to QE all over M. The equation of the motion of charged particles in electric field is not something abstract. All you need to do is write the equation of motion you know, anyone you know. Write it down. Example, V equal to U plus AT. And what do? Put in the value of the A, which is QE over M, where you have your acceleration, and get your solution for that particular parameter you're looking for. The same thing with every other equation of motion. Drift speed, we've done noble to that. That is the total distance traveled per unit time. I thank you so much for this lecture. It is a wonderful one. Make sure you watch it again and at least understand it perfectly well. Our next lecture will be on electric dipole, which is also a bit troublesome for students. They look at it as something that is very difficult. But in our next class, you will understand that dipole is very simple to work with, and it's also an easy topic, just like the one we've done today. Thank you. Have a wonderful time, and make sure that you share this particular lecture with your friends. Click on the subscribe button and also comment your feedback. Thanks, and have a wonderful day.